Indifference curve technique. An indifference curve is a graphical representation of the combinations of two goods or services that give a consumer the same level of satisfaction or utility. For example, if a consumer likes both apples and oranges, an indifference curve shows how many apples and oranges they would need to have the same happiness. An indifference curve has some important properties. It slopes downward from left to right, meaning that the consumer has to give up some of one good to get more of another good, and still be equally satisfied. It is convex to the origin, meaning that it becomes flatter as it moves away from the axes. This implies that the consumer has diminishing marginal rate of substitution, MRS, which is the amount of one good they are willing to give up for an extra unit of another good. It does not intersect with another indifference curve, meaning that there is only one level of satisfaction associated with each combination of goods. It is higher, farther from the origin, when the consumer has more of both goods, meaning that more is preferred to less. An indifference curve can be used to analyze how a consumer chooses the optimal combination of goods given their budget constraint, which is a line that shows all the possible combinations of goods that they can afford with their income and prices. The consumer's equilibrium is where the budget line is tangent to the indifference curve, meaning that the slope of the budget line equals the slope of the indifference curve, misses. At this point, the consumer maximizes their utility subject to their budget constraint. An indifference curve can also be used to show how a change in price or income affects the consumer's demand for goods. When the price of one good changes, the budget line rotates and the consumer moves to a new equilibrium point on a different indifference curve. This change in demand can be decomposed into two effects. The income effect, which is the change in demand due to the change in real income, purchasing power, caused by the price change. For example, when the price of apples falls, the consumer can buy more apples and oranges with their income, so their real income increases. This may increase or decrease their demand for apples depending on whether apples are a normal or an inferior good. The substitution effect, which is the change in demand due to the change in relative prices caused by the price change. For example, when the price of apples falls, apples become cheaper relative to oranges, so the consumer may substitute apples for oranges. This always increases their demand for apples. Theory of production. The theory of production explains how a firm transforms inputs, such as labor, capital, land and materials, into outputs, such as goods and services. It also analyzes how a firm chooses the optimal combination of inputs and outputs given its technology, costs and revenues. A firm's production function shows the maximum amount of output that it can produce with different combinations of inputs. For example, a firm's production function for pizza may show how many pizzas it can make with different amounts of workers and ovens. A production function has some important properties. It is increasing in inputs, meaning that more inputs lead to more output. It exhibits diminishing marginal product, MP, meaning that as more of one input is used, holding other inputs constant, the additional output from an extra unit of that input decreases. It exhibits diminishing returns to scale, DRS, meaning that as all inputs are increased by a certain proportion, output increases by a smaller proportion. A firm's isocant shows all the combinations of inputs that produce a given level of output. For example, an isocant for 100 pizzas may show how many workers and ovens are needed to make 100 pizzas. An isocant has some important properties. It slopes downward from left to right, meaning that the firm has to use less of one input to use more of another input and still produce the same output. It is convex to the origin, meaning that it becomes flatter as it moves away from the axes. This implies that the firm has diminishing marginal rate of technical substitution, MRTS, which is the amount of one input that can be replaced by an extra unit of another input without changing output. It does not intersect with another isocant, meaning that there is only one level of output associated with each combination of inputs. It is higher, farther from the origin, when output is higher. meaning that more inputs are needed to produce more output. An isocant can be used to analyze how a firm chooses the optimal combination of inputs given its cost constraint, which is a line that shows all the possible combinations of inputs that have the same total cost for the firm. The firm's total cost depends on its fixed costs, costs that do not vary with output, and variable costs, costs that vary with output. The firm's equilibrium is where the cost constraint is tangent to the isocant, meaning that the slope of the cost constraint equals the slope of the isocant, MRTS. At this point, the firm minimizes its total cost subject to its production function. An isocant can also be used to show how a change in input prices or output affects the firm's demand for inputs. When the price of one input changes, the cost constraint rotates and the firm moves to a new equilibrium point on a different isocant. This change in demand can be decomposed into two effects. The scale effect, which is the change in demand due to the change in output caused by the price change. For example, when the price of workers falls, the firm's total cost decreases, so it can produce more pizzas with its budget, so its output increases. This may increase or decrease its demand for workers depending on whether workers are a normal or an inferior input. The substitution effect, which is the change in demand due to the change in relative prices caused by the price change. For example, when the price of workers falls, workers become cheaper relative to ovens, so the firm may substitute workers for ovens. This always increases its demand for workers. Theory of cost and cost estimation. The theory of cost explains how a firm's total cost varies with its output level and input prices. It also analyzes how a firm chooses its optimal output level given its technology, costs and revenues. A firm's total cost function shows how much it costs to produce different levels of output with given input prices. For example, a firm's total cost function for pizza may show how much it costs to make different numbers of pizzas with given wages and rental rates for workers and ovens. A total cost function has some important properties. It is increasing in output, meaning that more output leads to higher total cost. It exhibits increasing marginal cost, MC, meaning that as output increases by 1 unit, holding input prices constant, total cost increases by more than before. It exhibits U-shaped average cost, AC, meaning that as output increases from zero, holding input prices constant, average cost first decreases and then increases. A firm's short-run cost function shows how its total cost varies with its output level when at least one input is fixed in quantity. For example, if a firm has a fixed number of ovens in the short run, its short-run cost function for pizza shows how much it costs to make different numbers of pizzas with given wages and rental rates for workers and ovens. A short-run cost function has some important properties. It consists of fixed costs, FC, which are costs that do not vary with output in the short run, such as rental payments for ovens, and variable costs, VC, which are costs that vary with output in the short run, such as wages for workers. It exhibits economies or diseconomies of scale, AOS or DOS, meaning that as all inputs are increased by a certain proportion in the short run, output increases by more or less than that proportion. A firm's long-run cost function shows how its total cost varies with its output level when all inputs are variable in quantity. For example, if a firm can adjust its number of ovens in the long run, its long-run cost function for pizza shows how much it costs to make different numbers of pizzas with given wages and rental rates for workers and ovens. A long-run cost function has some important properties. It does not consist of fixed costs or variable costs, since all costs are variable in the long run. It exhibits economies or diseconomies of scale or constant returns to scale, CRS, meaning that as all inputs are increased by a certain proportion in the long run, output increases by more or less than or equal to that proportion.